Hello, everybody. Welcome to today's masterclass on object-oriented programming with MATLAB. Thanks for joining me today. My name is Lauren, and I've worked at MathWorks almost 35 years now, and I try to do classes like today's to share my knowledge with people. You can find some previous recordings on YouTube, including the one from 2 weeks ago where I talked about programming with MATLAB. You might also find some useful MATLAB tips on the blog that I have on MathWorks site called The Art of MATLAB. So please put your questions in the chat and let's get rolling. Okay, so today's topic is object-oriented programming with MATLAB. I hope that's what you were expecting. And what I want to do is talk about why we even might care about object-oriented programming. Then I'm going to go into basic concepts and terminology, and a lot of this is independent of MATLAB, that part. And then I'm going to show you how to author your first class in MATLAB, and then making our classes more robust and talking about more of the object-oriented programming capabilities there are in MATLAB. Okay, so the example that I want to use today is to try to find from an array of sensors where the radar blips are coming from. So our goal is eventually to be able to find ones even if they're moving and not just stationary. Now with MATLAB, you have a choice about different programming techniques to use. And what's most appropriate really depends on what you're trying to do. So for example, if I'm trying to calculate the interest on my checking account, then I don't need anything fancy. I'm going to type 100 times 0.0000001 in the command window in MATLAB, and I'm going to find out that the bank gives me no interest, right? But I don't need to commit that to some big fancy program, probably. But there are times when I might want to do something in a more repetitive way, or not repetitive way, but even repeat it maybe monthly, or maybe I want to pass my code on to someone else. So there's reasons for me to sometimes think about either using some sort of point and click tool or command line and values like I just mentioned. But then I might get to the point where I want to do something a little bit more involved, and typing at the command line is not so easy to recreate. The next time I come in, I might forget a piece. And so maybe I start committing some of my code to a script, and I have some variables lying around. And as we keep going over to the right on this diagram, you see we have increasingly sophisticated data structures. So I might have different kinds of containers as we move to the right, structures, tables, things like that. And from the algorithm at the command line, I might move to scripts and then maybe to functions. And then ultimately, we will get to object-oriented programming here today. So the reason that we might choose any of these really depends on what the life cycle is and what the lifetime of what we're trying to program. So scripts and simple variables are great at automating small tasks. You have all your data in one workspace. So it's fine in some ways, but you could run into issues where you start overwriting things you didn't intend to overwrite. So that's where functions might come in. It allows you to scope variables into their own workspaces and avoiding confusion about what they modify. And structures might streamline the data storage, but are accessible and changeable to anyone. And then there's different kinds of functions. There's subfunctions, nested functions, anonymous functions. I covered those a couple weeks ago. And that gives you more control over the variable scope. But there are lots of issues here too. You can't associate functions with a specific particular kind of data. You can't have the function do different things on different kinds of data sets. And the functions all have to have unique names, and they're all on your path. And so that's how we'll show we can use object-oriented programming to address those shortcomings there. So here's the scenario that I want to talk about today. I want to have a sensor array, some array of sensors over here, and we want to locate where there's a weather balloon, and the weather balloon happens to be emitting a signal that gets transmitted to our array here. And the goal is from the angle of arrival of that information from the signals getting to these different towers, the differential basically between the way the time the signals get to these things tells us whether the balloon is over here or over here, or over there. Like, depends, it'll tell us sort of the angle. And so that's our goal right now. So I'm going to come over to MATLAB, and I'm going to do it just with a script to start. Okay, so I have here some MATLAB code. And by the way, we will be posting a place where you can download the code in the slides later on. So you'll be able to grab the code and try this stuff for yourselves afterwards. So I'm just going to run this. It happens to be a live script, and I use run a section and advance so often that you'll see that I made a copy of it on my quick access tool strip right here. So I'm just going to make sure I have nothing in my workspace here. And I'm going to define my radio beacon. It has, we have to know what the speed of light is. And we are going to have a frequency for the signal. And then I'm going to compute the wavelength and what the amplitude is. Another way I can compute this is right here. And then what I can do is I can say, well, I'm going to tell you the information about my balloon. My balloon has that signal in it, and its range is the far field, 1 × 10⁸ meters, and it's at a -10° angle of arrival. I don't want to complicate things with multiple balloons right now, so I'm going to skip that. And then what I'm going to do is I'm going to define my sensor array. So we're going to have 16 towers, sample rate, we're going to show there. We're going to have a noise ratio that we care about, a bunch of different parameters we care about. It's an FFT-based algorithm we're going to use, so we have a chance to potentially interpolate in the frequency domain, which means we're going to zero pad in the time domain. So I'm just going to set the parameters for my sensor array, and I'm not going to go out and actually gather the data. I've got a function that we made here, right here. Oops, that's so big. Okay, this is a sensor signal calculator, and we say where the target is and where the what the sensor's like, and then it will put out data that's appropriate for that. So I'm going to come back to my analyze data, and we're going to compute the sensor signal here, and then I'm going to use another function, the compute angle of arrival. Again, takes the array data and the sensor, and then you'll see it's using, it's going to zero pad things, and it's going to do an FFT. And if we come down here, you'll see that there's a mag FFT in here. There's peak detector. So there's a bunch of functions in there. And it's not my goal to describe all of these in any detail today, but it's all there, and you'll be able to see it. I see somehow we have angels here instead of angles. It's kind of cute. All right. So I've got my array data here. I just computed that, and it's a complex response. And now from that, I'm going to use my compute AOA that I just briefly showed you, and I'm going to compute the angle of arrival that it estimates. And you can see that it, whoops, well, now you can't. Let me make this a little bit bigger. Now you can see that it's going to show me what the sensor sees. So it sees at a bunch of different, as it looks from -100° to 100°, it sees different amplitudes of a signal, and it sees the highest one at, if we come down here, -9.5. Well, if you recall, I actually put the angle at -10. So that's not bad. Kind of good, right? But I told you we were going to do things like allow the possibility that we would do a longer FFT, we would pad more. And I don't know, I mean, I started off with 16 sensors, but I don't know if that's the right number, the number of detectors. So sensor dot num, whoops, num detectors equals 16. That's what I had there. So now let me come along here, and now let me recreate the data. It shouldn't change because I'm using the same number of detectors as I had before, and we get the same answer. Cool. Now let me come here and say, well, what if I had, do I get better resolution if I have more detectors. You'd think if I put more of them and had them closer together, there'd be more nuances that maybe I could use to figure out what's going on. So I'm going to recompute the signal, and I'm going to come here, and it didn't change at all. Well, maybe it's just not enough detectors. Since we're not actually putting these out in the field right now, I can go crazy with this. I can say, let's have 128 detectors. Okay, let's see if that helps us. So come here. Shoot, it didn't help us. Well, that's because I cheated. One of the things that happens if you have this data in a structure, there's nothing to protect the structure from getting new information. And in fact, if I come here and if we look at the sensor, you will see that I had a function, a field called num detector, but then I didn't show you that I was making num detectors. So this wasn't actually being used in my calculation at all. Okay, so now we think we know what we need to do, but I want to, first of all, let me delete that. We don't need that anymore. So let me come back here. And now let me come back up here, and you'll see I happen to be using some affordances from the live editor. I'm using controls, and I'm using a drop down, and now I'm going to say, let's do the same calculation now with 96 detectors. But now it's the right detector. Let me recalculate the data. Let me compute the angle of arrival. And now you see we get a little bit better angle of arrival, but not very much, not really. So now I might want to come here and say, what happens if I change the zero padding? And we'll change it to the maximum value right now. And now I'm going to come here, I'm going to recompute the data. And you can see I might need to, because you can see all these sharp jaggies, so I'm not really interpolating very smoothly. So if I do this now, we're interpolating much more smoothly. And now I get an angle of arrival much closer to -10, -9.9870. Okay, so it's kind of interesting. Now I'm going to put these back because this could get confounded early on if you make the problem more complicated than it was before. I'm going to come back here now, and I'm going to define the other two balloons. You're seeing I'm making an array of balloons. My first balloon was these particular values. They're all going to have the same signal and distance, but they're all going to be out there at different angles, an angle of 20 degrees and 25 degrees now. And now I'm going to set up my sensor array as it was originally. We'll compute the data as if there's signal coming from these three items now. And now I'm going to calculate the targets. And you'll see right now it only finds the one kind of near 25. And so it doesn't even think this reaches the threshold of enough of one of them. And the 20 and 25 seem to be blurred together. So what happens is if I come here and I change the zero padding, let's see what happens, the effect of each of these separately. And now let me compute the angle of arrivals here. And now you'll see I don't do that much better. So in fact, it's true that I need more sensors here, more detectors. So let me get more detectors here. Let's recompute the data, the synthetic data. And now let me get the answer. And now you'll see we found three signals, or three blips out there, near -10, near 20, and near 25. So we needed the combination of the FFT padding and the number of detectors being increased in order for us to get the answer that we knew we put in the first place. So that's kind of nice. But if I come back to my slides, one of the things you'll note, this was super easy to put together, right? My script was pretty easy. I didn't have to plan a lot. I could change parameters, but there was no formal relationship between the data and the functions. And so I showed you everything in there. And maybe you don't really need to know in the end what the speed of light is that we're using right now. Maybe that's something that just shouldn't concern you. And in fact, it might be particular to the kind of sensor I'm using. So we're exposing all these details, and it was very easy for me to break. Like I put in the name, I put in, I thought was the right name, the num detector, but it was not the right name. And I didn't actually affect the algorithm at all. And so we would like to make something that's not quite so fragile there. And so what I want to do now is I want to think about how to move forward. So I want to move on to object-oriented programming. And I'm going to give you just a really brief highlight of what that is. So I showed you the progression before, whether it's point and click or command line stuff, scripts and functions. But when we get to a class actually encapsulates and embodies both properties and methods. In other words, it includes data that's relevant and includes the algorithms. So let me explain a little bit more about this. A class is basically a blueprint or an idea or a concept for creating an object. And an object is an instance of the class. But the class has some properties. It could have data. It might have state. And the methods include algorithms and behavior. Let me give you a concrete example here. And then I said, when we make a specific instance of a class, that's called an object. Suppose I have a class called dog, and it's got some properties, breed, age, and color. And then it's got things dogs can do: eat, sit, and bark. And here's two objects of those classes or instances, Lexi and Luna. And you can see they're different breeds, they're different ages, different colors, but they can all both eat, sit, and bark. Okay, so I want to build a simple class right now because I don't want to get in this situation again. So I'm going to come here back to my MATLAB. I shouldn't really have done that. Let me come back like that. Okay, and now what I'm going to do is I'm going to say I want a new class. So I'm going to make a class, and I'm going to call it Blip. And I'm going to remove the methods for right now, but I need an end statement. You see the code analyzer was cranky before I put that end back. And I want to say this is our class Blip. Blip for source of. Okay, and then this Blip is a simulated weather balloon. All right, and the properties we had before, well, it had an angle of arrival, it had a range, that was the far field that I told you, and it had a signal that was embedded in it. So I can save this, and I'm going to save it here. And you're going, well, how did this get easier? I'm creating another file now. How's that good? Well, let me come to our analyze data script. What I want to do is I want to clear out my workspace. And I actually use the quick access toolbar, not just for the run in advance that I have here, but you'll see that I have favorites. So this one clears the command, clears the workspace, clears the command window. And if I happen to be using figure windows, it closes them, but I don't have them because I'm working in the live script here. So I'm going to go here. If you look in my workspace, I no longer have anything in it. And in fact, I can clear all the output here. And now we can come in, and there's only one change I'm going to make. I'm going to say balloon equals Blip. Okay, so now let me come here. Save it, although I don't really have to. Let's run a section in advance. We're going to create our radio beacon. We're going to define the balloon, and now it's a blip. Okay, and now I'm going to create my multiple balloons, and I create my detector and all that sort of stuff, the sensor, create the data for simulation, and now I estimate the arrival, and you can see I get the same answers I got before, which is really nice. But I have a new file now. Well, what's the point? Well, let me come here just to the command window for a moment, and let's look at sensor. So we look at the sensor, it's got all these fields. If I go, I don't really like being called num detector, I can say, whoops, sensor dot num detector. I can go like that, command line, the tab recall, but I'm going to put another name letter on it like I did before. And let's make this one be, 24. What? Oh, that's the sensors. Sorry. Of course I can do that with that. That didn't help. My balloon is now an array. So we can look at it just the same way we looked before. I can say balloon of 1, and we can see that we can say, balloon of 1 dot AOA, and we can find out its value. But now I can, if I made a mistake, I can say dot AOA, and now you'll see I get an error message because MATLAB is case sensitive when it comes to these things. So MATLAB is also very politely trying to offer help here for what I could do. And of course, that was exactly what I meant. But the class actually protects you from making sort of mistakes that are possibly confusing changes that you didn't mean to make. It will actually stop you from doing that. And so for having this one extra file here, my Blip file, I get a lot of good out of that right now. Okay. And I showed you the tab completion. That's really nice. So I can come here. We can say balloon dot. If I just do tab, I can see what the different possible data fields are in there. Properties they are called when they are in a object. Okay, so all right, that's all well and good, but if I do this, then if I created my Blip, notice what I had to do before. What I had to do is I still had to say for balloon of 1, what's the AOA and the range and the signal, and then I had to do it again for balloon of 2 and balloon of 3. Well, that's a little bit of a drag. So let me come over here. I'm actually running this from a project, and I'm going to start back to our simple class here, and I'm going to clear my workspace. I'm going to run this. Okay, and this is our class 2. That's basically what I showed you before. Let me get rid of my old ones now. So now I have the basically the same file that we had before, except for you'll notice that I have the balloon equals Blip in there. Okay, but now maybe I want to do something else. And so let me, in Blip, let it say what it is. Let's identify itself. So I'm going to put in a method called identify, and methods are basically put in by putting in functions. And I'm going to say identify, and with one exception, all methods in the oh, it already put the end in for me. I actually, that's a choice in the preferences in the editor. With one exception, I always need to have an object. You can name it anything. I'm naming it object. You could have it be this. You could have it be any name you want. But it has to be intended to be an object of the class from the class file that we're looking at. So you'll see we have this class def, and we have a section here of the properties. And now I'm putting the methods, which are the algorithms. And the identify is I want to say disp. And so I'm going to say disp. Let me go like this. I'm friendly and arriving at, and then we'll go plus AOA plus. Okay, so let me try to run this. And so we go, what we need to do is I need to come back to my script here, and let's get going. Let's run some of this. So now I've got my signal, and now I've got my blip balloons, and now I could say identify balloon of 1. And it says there's an error. It doesn't recognize that. And in fact, if you come here, you'll see the code analyzer is actually trying to tell me something. It's confused because I'm using AOA. And if I want to use AOA, I actually have to use this particular object's AOA. So I need to go like this. Okay. And when I do that, one of the things you'll notice is that now instead of having any warnings, I don't. So if I come back here and I say identify balloon of 1, I get unfriendly and I'm arriving at -10 degrees. Now, for those of you who may have done object-oriented programming in another language, you might think this identify is really weird. I could have said balloon of 1 dot identify. So I can do it either way. But I'm doing it in the way that's more like a function syntax because I think that's what MATLAB users are more typically used to. Now, once I create this and I have my method, you'll notice something else. I am still stuck with having to write all these lines of code to set up my values. It'd be awfully cool to have my blip actually let me set it when I create it. And so I'm going to put in what I'm going to call the constructor. Okay, and that is blip. And this is the one function that does not take an object as an input, but it returns one as an output. Okay, and my blip, I'm going to let someone hand in AOA, range, and signal. And now you're thinking, how did this ever work before? We had a function call. We called blip, and there was no blip function. How did that work? Well, we have something in MATLAB called the constructor and the default constructor, so that if you just give the name of the class, it should return maybe an empty version of the class, but something of that class. So now I can say obj.aoa, thank you, equals AOA, obj.range equals range, and obj dot signal equals the signal. But if I do this, I am no longer going to have the default constructor. So if I call blip, it says, oh, there's not enough inputs. So I'm going to come in here and I'm going to preserve that ability to create a default constructor. And I'm going to say if nr again equals 3, I'm going to end my thing, and I'm going to go like this, and I'm going to do indent. Okay, and now if nr again is not 3, it should create a blip. So let's just create a blip, and now we get an empty blip. So now that I've made that, what can I do? Well, I can come over here and I can change each one of these things into something else. So let me come over here. I think I'm going to just show you by coming into the third version here. And this is the third version. So let me get rid of my old ones. 2, 2, 2, 2. Hopefully this is the new one. Nope. 2. Okay. So that's a version 3. Okay, let me clear everything out. Well, I don't have to. I can just run this. But I want to show you blip. So blip now has the same code you just saw me create, although got named a little bit differently here. And you see the same sort of identify text there. And I've also turned the sensor into a class. But we can still change everything here. So if we look at this, I'll come and look at the sensor in just a minute. Let's come over here. And let me run a section and run a section. And now you'll see I could create my balloon the usual way. or I can call it with the 3 inputs, either way. And so this saves me a whole lot of typing because I can just do it by that, the code that we added there to allow me to have 3 inputs there. And now I can create the sensor array. And now, since it's an object also, we look in my workspace browser, you'll see that we have, let me see if I can make this nicer here. Somehow I have all these other ones, but they're way over there. Let's make this way smaller. That's nicer. Okay, so I've got a 1x1 sensor. I've got my signal that's a struct right now, and I've got my balloon that's a blip. Notice that it says that it's a blip there now. Cool. Okay, so I've got my staring array, and now I can compute my AOA without having to ever change it because it's using the same notation that we used from the structure to get the fields of the properties. And so you'll see we get the same values we could, because of course we didn't really expect to, I don't know why there's 2 of those. That didn't make sense. Okay, we just copied and pasted too much there. Well, just showing you the both ways that we can call staring array also. So our compute AOA, I can call it, it's a method of the class staring array. And so I can just call that function on the class. Okay, so now we've got a class. Here's our class Blip, and it has some properties. But, you know, maybe I know that there's often properties, like if we look in the sensor, let's come back down here now for a minute, and let's look at sensor. Here's my sensor. I can change all of these things right now. I can change, let's see. I can change the noise ratio. There's nothing preventing me from changing it. Oh, it must be accessed from a class. Oh, because it was not a constant property. Okay. I didn't see how the sensor was implemented here. So the sensor was actually implemented. These are all right. Well, let me come here, and I want to show you how I can do this. So it might be nice if I had default values for some of these particular properties now. And so what I'd like to do is come over to my project, and let's open the encapsulation section. And in the encapsulation section, you'll see the same code that we've had before for the blip. And now let me get rid of some of these things. Okay, and let's clear everything out. But now you'll see that what I'm doing is I'm going to put in some information here to make sure that I don't do something, or that someone else doesn't do something that I don't like. So I'm going to make sure that even if they can change num detector, it's always going to be a 1x1. Not trying to move this, a 1x1, a double, and it must be an integer and it must be positive. And I'm going to give it a default value there as well. Okay. And I can do similar things with the 0 padding. And then if I want, I can change by default. What's happening here is that these are the things maybe that I want people to change. So I can come over here and I can say, sure, go ahead and change those. But now I want my other properties, and let me bring this, whoops. I want to go like this. To get access, I want people to be able to see these things, but I don't want them to be able to change them, so they're protected. And then properties. And now these, I might want to keep constant and hidden. Okay, and I've got something that's not right here. Or is it error might be? Oh, Okay, so now if I try to use these, I can come over here and let's come back to our, clear this out, clear all the output. And now let me come here. We'll create our signal. We'll create our balloons. We're now going to call our sensor. And now staring array has some properties, but if I go, whoops, if I come like this, I can say staring array dot, I think I'm making the same mistake I made before because it's not the sensor that I wanted to do. Yeah, well, these are the sensors. So I can no longer find speed of light, but I can do num detector. So, so if I try speed of light, it tells it to me, but if you notice when I print it out, it's hidden, but I'm still allowed to look at it. But if I tried to change it to 8, it's saying, sorry, you can't do that. It's a constant, which makes it read only. Okay. And then if you supply some things, I can also make wavelength and spacing be dependent. They're dependent on one another. And so what I could do is I could then have specific methods called getter methods. And they're very strange names. It's get.wavelength and get.spacer. And it allows you to do things like staring array.wavelength. So it will allow you to actually access them in the usual way. And that's the way you indicate to MATLAB that you want that to change. Let me come over here. I know there's a couple questions. I will talk about mixins later. I want to wait towards the farther end, and find obj I will also talk about in a little bit because I want to get to a different topic first. I didn't mean to bring up the help just now, but actually I should have done that. I should have let that happen. Let me bring up the help, and let me look at attribute. Attributes. Attribute property. Let me think about what I want to do here. I think I want to look like this. Property attributes. That will be a little more helpful. Okay, so I'm going to come here and I'm going to show you all the attributes that we have. So there's a lot of things. I showed you a few here in the code. You could see that there were ones like constant and hidden, public and protected, and so on. It also turns out that I have, I can make a class abstract so that you can't make one of them at all. The access we showed a little bit. I can have the dependent properties by default. You can see what the defaults are and all of these. So a lot of ways to control the information. And I want to come over here to talk about that. So before I did anything with these properties and attributes, what I had was I had a whole mess of information from the sensors, both the methods and the properties. And they were kind of just all together, and they didn't all have the same importance, but to me, I didn't know that if I was the consumer of this. And so what this allows me to do, the encapsulation, is to have all that information in there, but reorganize it in a way that we're only going to show certain things here, but we're going to allow certain other things to happen here. So it separates the interface from the implementation. The reason you hear people say that's important is because it allows me to go in later and maybe my compute AOA, maybe you can use it, but you can't change it. And the nice thing is, if I need to, maybe I'm going to use a different method sometime, maybe not a compute-based, an FFT-based method. You don't need to know that it's not FFT-based anymore because I never had the padding, the zero padding available to you here. So you didn't necessarily know there was an FFT behind the scenes. And so it simplifies the object use where I'm only showing you the things that you really need to know about, the levers that I really want you to use and the methods that I really want you to use. So it makes it simpler for you to use. And it also becomes a building block I could use these for something else. And then I showed you controlling the access. There's public and protected. You put them in blocks, as we just showed. And we also can restrict modifications. They can either be constant or make things dependent on one another. And again, we can come over to the documentation and find more of that information out. Now, the next thing I want to talk about is inheritance, because if we have a class that does something we want, but we want to make it a little more specific for certain cases, I don't want to rewrite and duplicate all that code. So here's an example. We have an example of an employee. And at MathWorks, we certainly have many different kinds of employees, but we certainly have engineers and we have salespeople. And they have different attributes there. So, but they're both employees. And like engineers might have products and teams they work on. And properties of a salesperson might be their region that they cover and the commission that they get. And what they do is prospect, and they're a salesperson. And we also have a specific kind of engineer that does testing. So you see that when I do this, I want the engineer to also get all the properties that are of the employee, and the same for the salesperson, and the same for the test engineer, who can work on these specialized properties, but also all the properties that an engineer has and all the ones that an employee has. So subclass substitutes for the superclass. It allows us to rethink about, oops, that's not what I meant to do. Sorry about that. It allows us to rethink how to reuse the class, and lets us think about something else we might want to do. And it builds on code that's already working, and we don't want to mess with that maybe. And then it also allows us to inherit from the base MATLAB class. Now, before I get into the actual example, I want to talk a little bit about some stuff here. So what I want to do is think about let me just come to the command line here. Come to our MATLAB, come here. Let's clear everything out. Okay, if I say x equals 4 and y equals x, and then x equals 5, what do you think y is going to be? Well, you know the way MATLAB normally handles things, it basically is going to change when I say y equals x, it immediately puts the value 4 into y. But when I change x, it doesn't change y. That's because it's called what's called x and y are what's called value classes. Okay, but now suppose I do h equals, and let's make a plot here. So here I've got a plot. And now if I say capital H equals the same thing as my h, and now I say capital H dot line width equals 15. Actually, let me do lowercase one, the original one. What do you think the line width is for capital H? If we look, you'll see that it is also 15 here. Here's capital H now. So H and uppercase H are actually referring to the same things. H, in this case, is a handle class. It's a reference to the one and only line that we're referring to in this case. So you might want to use handle classes some of the times. We don't use it typically in MATLAB for mathematical entities, because we've set up something for years where you're expecting the behavior that I showed you with right here with the regular class x equals 4, y equals x, x equals 5, and y has not changed. But there are reasons sometimes to do things with handle classes instead. And so I want to show you what that might be. So I might want to inherit. Oh, I thought I was going to have a slide here. Ha, okay. Well, I'm going to come over here instead. And we're going to come to my project, and I'm going to work on inheritance. And now you'll see, if we look in the current folder, I've got my sensor, I've got a blip, and I've got my analyze script there. I'm going to clear all the information out that was in there, my workspace. And now what I want to do is I want to think about a time where I'm going to have a blip. Notice I've changed blip now to be a handle class. And this is how you inherit from a class. You just give it the less than sign and handle, because blip is contained in that class. It contains that class. So I've got the properties here, and the rest of the code is all the same. So it's going to look pretty similar. But the reason I want to do this is because I want to have a class that's not just the regular satellites we have out there, the regular balloons we have out there, but rather I want to have some that might be moving, and they might be untethered. So for that, I want my moving one to still be a blip. And so I'm going to come over here and we're going to look at the blip. And here, moving blip is a blip. But you'll see what I'm going to do is I'm going to add a delta AOA to the properties. And so what I'm going to do is I'm going to also have a method here. It has all the same methods that blip has, which were, if we come here, excuse me, it was the blip, a constructor, and identify. That was it. But a moving blip is going to add a new method to how to move it. And so the first thing I need to do when I create my moving blip, I'm going to return an object of that class, is you'll see that the object is going to, when I create the moving blip, is it's first going to create the superclass. So it's going to create the blip from the input arguments here. And then, because the trailing ones are going to be the ones we want for the original blip class. And then if we have a delta AOA, what we're going to do is assign the object's delta AOA to that value. And then I'm going to have a method called move. And my move is going to take the object and move it. And if I didn't have the handle class here, I'd have to output the object. If it was just a value class, I'd have to have the output class come out, because otherwise I'm not returning anything. A value class has to return something. It doesn't only act on its input, but it has to return an output. You will see in a moment that I don't actually need to do that here, but I'm going to just say, take my angle of arrival and change it. So we're going to do that in a bunch of time steps. And then just so the plot doesn't get way far away, I'm going to make it turn backwards if we get to a certain point. So I'm going to come here, and now let's see what's going on. So come here, get our signal set up. You'll see now that I'm creating 3 balloons. They're not all the same kind, so I'm putting them into a cell array instead of one big array, because, well, a moving blip is a blip. A blip is not a moving blip necessarily. And let me show you what that is. I can come here and I can say, is a, balloon of 1. Okay, it is. And is a balloon of 3 a blip? It is. Is balloon of 1 moving blip? No. Is number 3 a moving blip? Yes. So, so that's interesting that it knows that, right? Okay, and if we look in the workspace, we will see that. We will just see the cell array, but now I can click, whoops, come here, and we can open this. And now we will see that we have 3 things in here. We have a blip, whoops, and a moving blip. Okay. So let me come back here. So we're down to here. I created my array of targets there. I'm going to compute the sensor information, and I'm going to compute the angle of arrival that should be there for these, the data for these. And now what I'm going to do, that's just for step number 1. Now let me come like this. Let me go like this. And now what I'm going to do is you'll see that I'm going to go 15 steps. And since my moving blip is actually a handle class, I don't have to return the output anymore here. So let's see what happens when I run this. You can see it go through its 15 time steps as it moves. Okay, and we get the final answer at the end. And you'll also see that if I wish to, I can replay that now, and we can see how that third one moved. So that's really kind of nice. All right. I showed you inheritance. You can also view class hierarchies with MATLAB's class diagram viewer. And that can be a really nice way to see how everything, because often you have something that's a bit more complex than the one that I've showed you for this example. And let me see. Just to mention something, for those of you who may have used MATLAB for a long time and may have used an older style of object orientation, we had one starting in 1997, I think it was. We massively changed it in 2008, and the legacy class system is still there, but it has limited functionality. But the current one has all the things that modern class systems have, object-oriented systems have. All right. You can do even more with object-oriented programming. You can have classes in multiple files. You can put packages, functions in packages for creating different kinds of namespaces. You can, in fact, use mixins and heterogeneous arrays. And there was a question earlier about MATLAB mixin classes, and mixin classes are often very nice to use. They are a little bit more advanced to use than what we've been doing so far today. Let me get to the help here. Let's go mixin. And let's go here. See if we can. This enforces. This one happens to be for a scalar. That's not what I wanted to do, but you'll see. It's a way of getting some information into mixin. Let me go just mixin. Results for mixin, that's okay. It's a way to customize your class. As you saw just a moment ago, we have some specialized ones already. Like you might have all the information you want in your class, but you want people to only not be able to create an array of it, but just a scalar version of it. So if you if you include the mixin there, and one of the nice things for all this, I should say, is when you come to these pages, you should see an example. So here's a struct scalar class. So with it, the struct scalar class is going to inherit from a mixin where we're going to redefine the dot for indexing, and from a scalar class. And so I don't have to write the information now to make it a scalar, because it's going to adopt that. So using mixins can be very, very valuable without you having to write a lot of new code. So if we have mixins that you want to use, it's a great way to go. And if you have ones that you'd like to see that we don't have, please contact us and put in a request for an enhancement on that. Okay, so that's mixin classes. They're not bad to use at all if it will constrain your object in the way that you want, and it will limit you having to write all the extra code that would enforce that. And then find obj. I'm not sure I have a lot to say on find obj, but let me look at that. Let's see, find obj here. Let's see what it has to say. I don't have a lot to say about it. I don't tend to use it. What I tend to do myself is, if I know that there's particular objects that I'm going to need to worry about later, like for example, if you're using App Designer, the code that gets generated from that is object-oriented code. If you have some particular objects in your canvas that you know you want to really work with, you name them very carefully and you keep track of that name, and then you know you don't have to find it. You can actually have it there as part of the information that you keep lying around. So I don't tend to use find obj because it takes a while to go through everything potentially and find it. can we create interfaces in MATLAB? You can. I'm just trying to see, not if it shows here. You can. I don't think it's exactly the same way that maybe you do it in other systems, but you can create interfaces. I guess what I tend to do, I've not done that. I've usually created an abstract class for a good reason and then subclassed from it and made concrete classes after that. Let's see what else we've got here. Someone wants to know abstract classes versus super classes. As I said, I tend to make a super class in general, and if there's interfaces that I want to enforce, I put all the methods in there. But usually I make it an abstract class unless I can actually make one of my super class. I'm having trouble thinking. So if we thought about, I am not a controls person, but there's a lot of way to look at control systems. And one is with a set of state space matrices. One is through linear time invariant object. One is through ABCD matrices. So you might want a class that is what these all are, and then but you can't make one of these abstract ones. You have to, when you make one, you have to make one that's either a linear time invariant class or a state space variant of the class or an ABCD variant of the class. And as a result, you might have interfaces to each part that are slightly different because maybe they take different inputs, whether it's ABCD or some other structure, numerator and denominator or whatever. I would make an abstract class if there's a principle that I want a whole bunch of other classes to obey, but there's nothing that I can instantiate in the main class that really makes any sense. Like I said, with the control systems idea, you actually are always going to make something representing a physical system, whether it's state space version or numerator denominator or something like that. Hopefully that gives you some material on that. Let me come back to the slides now. I think I've got that covered there so far. So I was just saying before, there's more that we can do with object-oriented programming in MATLAB, classes in multiple files, the mixins and heterogeneous. We just talked about it just a little bit. I didn't talk about heterogeneous. I can actually make a heterogeneous array. So for example, if I want to, I have to use a mixin to do it, but I could have then taken my blips and my moving blips, and I could have put them into a heterogeneous array, which would have been a blip array when all things were in it. But if I extract just the moving blip, it would be a moving blip. And if I take it out, then what I'm left with is a blip array. But I could combine them since they all have a common super class. So you can put things in heterogeneous arrays if they share a common super class. And sometimes that's very useful because maybe there's a high level property that they all share and you want to work with that all at once, or a high level method. And you can work with them all in a row together there. You can also find out information about the class itself. And if you want to, you can customize indexing and unit indexing. And we've made that easier in the current release. So in fact, if I come over to here to MATLAB and we come to the release notes, I think here we will come to external language software development tools. Maybe not there, maybe it's language. External language interfaces. I never know exactly where things are created, but for load, so there, I can't find it right now, but there's information that you can find out for overloading different kinds of indexing. So if you don't want open paren 1 close paren to be index and get me the first value in my class, you can do something else instead. You can change it by overloading the indexing, and you can overload them preferentially for dot or brace or parens. And you can also incorporate unit testing, and that's really, really key. Because if you're creating a class, usually this is because you're investing in something that's important and you're going to keep it a long time. And so if you ever go and change it and update it and add functionality to it, you want to make sure you didn't break anything else. And so for that, you would want to have some unit tests available as well. If this was interesting and helpful, what you might think about is taking the class that we have on object-oriented programming. Many of you might be at a location where you already have some training available from us. Maybe certainly people who are at a MATLAB-enabled campus, you might have that available. So if not, come to our site and find out more about it. And one of them classes, of course, is object-oriented programming with MATLAB. So I recommend that highly. There's a lot of great documentation there, a lot of examples. So definitely take advantage of those. And I just wanted to see if I can have my my documentation here. I want to come to, no, that's not what I want. I want to come back to all products. I want to come to MATLAB, and then let's go to examples. And now I can start drilling down in examples here and find information. And there's a lot of MATLAB examples. So actually I should look at the programming ones maybe. And hopefully you'll find some information there that create composite system object, different kinds of things there. So you'll be able to find information that you need and demos that might be useful to you by poking around inside the demos there. Okay, let's see if there's anything else. A heterogeneous array could be more useful than a cell array. Thank you for asking that. Because a cell array, you definitely have to do the curly bracing and pull each thing out and work on each one independently. If you have the luxury of putting something in a heterogeneous array and their superclass has the method, multiply in it, then you can multiply that whole array times whatever else you were going to do without having to do something special and pull things out one by one. So if you can make it heterogeneous, there are often advantages to it because it's a little less clunky to work with. But then you have to set it up that way so that things will work that way for you. So it's not a bad idea, but it's definitely not the first thing you do when you're making a class for the first time. Any more questions? Now would be a good time to put in your last questions because we're just about finished. And while you're putting in your last questions, I want to thank you very much for attending and watching. We'll put some links below in the description that you might find interesting. We actually have recently started another Simulink student challenge for this year. And please don't forget to subscribe to the MathWorks channel to get reminders for next events. Thank you very much for attending.